Consider elastic collision of a particle of mass m moving with a velocity u with another particle of the same mass at rest. After the collision, the projectile and the struck particle move in directions making θ1 and θ2 respectively with the initial direction of motion. The sum of the angles θ1 plus θ2 is to be found out. So here we have two bodies that are about to make an oblique collision with each other. One body is moving horizontally with velocity u and the other body is at rest. So now both bodies would face an impulse, and that impulse would be perpendicular to the surface of collision. Therefore, we have a change in velocity of delta v felt by both the particles in perfectly opposite directions. And since delta v is the only velocity that the second particle has, this angle is equal to θ2, which is the angle of the final velocity of the struck particle with respect to the initial direction of motion of the projectile. In a elastic collision, we can conserve kinetic energy before and after the collision. So we have 1 by 2 mu squared. This is the total kinetic energy before the collision. And what is the total kinetic energy after the collision? We have 1 by 2 m delta v squared for the kinetic energy of the second particle plus 1 by 2 into m times. To find v square of the first particle, we can just add the square of the velocities in the x and y directions. So the x velocity is u minus delta v cos θ2 whole square, and the y velocity is delta v sin θ2 whole squared. 1 by 2 m can be taken out of the equation right here, and we have u squared is equal to delta v squared plus, expanding all these brackets inside, u squared plus delta v squared cos square θ2 minus 2u delta v cos θ2 plus delta v square sin θ2 sin square θ2. Now even u square can be taken out of the equation, and we have 2u delta v cos θ2 is equal to delta v squared plus delta v squared. The second delta v squared comes from these two terms here, delta v square cos square θ2 and the sin square θ2. So we have u delta v cos θ2 is equal to delta v squared. Now of course this is a quadratic equation and has two solutions, but one of them is a physically impossible case where delta v is equal to 0, which means that a collision has not happened. So the second solution is all we care about, where delta v is equal to u cos θ2. Now let's see if we can find θ1 in terms of θ2. So we know that the first particle was moving with a velocity u and it experienced an impulse of magnitude delta v, and this angle is θ2. So the resultant velocity would have vertical and horizontal components, where the vertical component is delta v sin θ2 and the horizontal component is u minus delta v cos θ2, and this angle is θ1. Therefore we have tan theta 1 is equal to delta V sin theta 2 by u minus delta V cos theta 2. But as we already saw, delta V is u cos theta 2. So we can just substitute that in this equation. Tan theta 1 is equal to u cos theta 2 sin theta 2 by u minus u cos square theta 2, or this is equal to u cos theta 2 sin theta 2 divided by u sin square theta 2. Therefore, this gives us tan theta 1 is equal to, we can have u cancel out, sin theta 2 cancel out, cos theta 2 by sin theta 2 is cot theta 2. And if theta 1 and theta 2 are complementary angles as given by this equation here, the sum of theta 1 and theta 2 must be 90 degrees.